All right. We're going to start a new chapter. We're going to now deal with equations that in the past we couldn't answer. In other words, if I gave you this equation, what are my solutions? How many solutions can I have to begin with? The degree tells you the number of solutions possible. What does this graph look like? It's a parabola. If you think about it, remember, what are solutions? X-intercepts. So we can have two X-intercepts, we can have one X-intercept, or we can have no X-intercepts. So we know we're supposed to have two answers. Oh, in the back, if you have chapter 3 already, great. I also put chapter 4 in there also. Because yes, I know we'll definitely finish chapter 3 next week. And so we'll start chapter 4 also. All right, so how would you solve this? Right? That's right. I already bored you already. Just got here. Now what? So the square root and the square cancel. And it equals what? Yes and no. Because remember, we're supposed to have two answers. We're supposed to have positive or negative 2. Whenever you square root an even degree term, you must place a plus minus in front of the solution. That's what we get to. Yes. If it's odd degree, it is what it is. If it's positive, it's positive. It's negative, it's negative. Graphically, we can see what that's all about. If I put a 2 inside the x squared equation, what do I get? If I put a negative 2 in there, what do I get? I also get 4. So there has to be two solutions. So y equals x squared. If I put a positive 2 in there, y equals 4. If I put a negative, the same number in there, I get a positive 4. That's the reason why we put plus or minus in front of the even terms, even degrees. So if the degrees 2, 4, 6, 8, 10, any even degree. Now, good question. What about if it's an odd degree? If the degree is odd, The answer is what it is. What does the x cubed function look like? Yes, it's an increasing function. It actually looks like this function. Except if x is negative, -2 times -2 times -2 is what? Yeah, -8. So if it's positive, the answer is positive. If it's negative, the answer is negative because you have an odd number of signs. So far, so good. All right. What if I gave you this example and asked you to solve it? X squared equals -9. So that becomes x plus minus square root of -9. What two numbers multiplied, same numbers, give you -9 if you multiply them together? -3 times -3 is +3. So here we have the problem. So in our realm, we have two types of numbers. We have real numbers and imaginary numbers. By definition, you know the definition of imaginary numbers? Numbers that are not real. Exactly. Mathematicians are not too creative when it comes to naming things. So, because this is a possibility, there has to be a value to it. You can't graph it. It doesn't fit on a two-dimensional plane. It's somewhere in the third dimension. So what we're looking at is every number can be expressed as this form. We now have what are called imaginary numbers, the letter I. Every number is made up in this format. I stands for the square root of -1. So our answer, the square root of -9, we can split these up to be -1 times 9, which expands to square root of -1 times the square root of 9. Square root of -1 is I. Square root of 9 is 3. So the answer is written as 3i. Because now we have no limit in what we can solve. So let's look at some properties of radicals first. Here's some properties of radicals. If I have a product of two or more numbers or letters or whatever, I can split them up into individual radical components. Here's an example. Square root of 36. We know what that is already. Let's see how it works using this rule. 36 is made up of what? 4 times 9. Yeah, I said we know it's 6 times 6. That's too easy. But now let's look at this. If we split them up, we have the square root of 4 and the square root of 9. The square root of 4 is 2. Square root of 9, 2 times 3 is 6. Yeah, even though we did know that 36 is 6 times 6, so it equals 6. But there's more than one way of doing it. So if I had square root of 25x squared. Sure. Well, yeah, but to split them up. We split them up. Square root of 25. Square root of x squared. X is 5. That's the first one. Then we have the quotient rule. If you have a quotient inside a radical, you can, if you can't do anything like this, then you can split them up and maybe this might work a little bit better. And the rule of math says that you cannot have radicals on the bottom. So, but this is the property. But the rules of math says we can't have, and I'll show you how to get rid of those. So let's say we had the square root of 4 over 9. We can't do anything with these two, so we can split them up, see if that does anything for us. Square root of 4 is 2 over 3. So you can put the equation in any way you want to. For example, that one. Square root of 27 over square root of 3. Are either of these perfect squares? No. So there's two ways we can do this. One way is we can put them under the same radical. Does 3 go into 27? How many times? 9. Square root of 9 is 3. So it's where, or we could have go back to the original formula. What's 27 made up of? 3 times 9. I had one student always said 1 times 27. Okay, what's kept on saying over and over and over. So here's your sign. Now we could break up these two. We have square root of 3 times square root of 9 over square root of 3. Yeah, I chopped my face up this morning with my razor. I forgot to tighten it. I have one of those razor blade ones. I forgot to tighten it so the blade's going. I mean, it's like squirt, squirt. So can anything cancel? So we're left with square root of 9, which is 3. As long as you follow the rules, you can't go wrong. If we had this, you cannot have radicals on the bottom. This is what's called rationalizing the denominator. So to get rid of the square root on the bottom, what do we have to do? Now, if we square the whole thing, then we just explode the whole number. How do we get rid of it? Well, no. That is one way, but it's not the right way. If we multiply the top and bottom by square root of 3, so we have 2 square root of 3, and on the bottom, square root of 3, square root of 3, we have 3 times 3. So we have square root of 9, which makes it 3 on the bottom. So multiply by what you need, how many you need on the bottom. Because since it's a square root, how many 3s do we need inside the radical? You need to have 2 of them. So we only have 1, so we have to multiply by another one. The reason I'm saying that, let's do another one like this, and then I'll show you what I mean by what I just said there. So what do we do here? Square root of 5 over square root of 7, which is multiply square root of 7 divided by square root of 7. On top, it gives us the square root of 35, which is 5 times 7. On the bottom, no. So it's 7, it's 49. So square root of 49 is 7. And 35 doesn't break down any, because it's made up of 2 prime numbers, 5 and 7. So that's rationalizing the denominator, which is going to be important at the end of this section we're talking about here. All right. So what's that going to equal? Right, because basically, if you have a negative inside the square root, that becomes the I. So we remove the negative, we just have square root of 16. And square root of 16 is 4i. Let's see. How about this one? Anybody agree? What should it be? Yeah. Because the only thing we take out of there is that negative, makes it an I. Square root of 3 is just square root of 3. So let's look at example 1. A is the square root of negative 7. which becomes what? Like that? Yeah, so whenever you have that, when you have a radical, put the I in front. So it doesn't, a lot of times, like myself, we put that little tail on the back. But if you forget, that's still confusing. You'll get very confused in that. So put the I in front if it's a radical. B, square root of negative 16. You were getting there. Negative square root of negative 13. Square root of negative 64. Very good. Because we know now that we can't distribute inside there. So if it's a negative in front, the answer is going to be negative. If it's got a negative inside the square root, it's going to have an I. So we just look at square root of 64 is 8 times 8. Now, what do you do if you don't see that? If it's a number that you don't recognize, if I put 268, what would that be? If you don't see it's a perfect square, take the number and prime factorize it. Take it down to its prime numbers. 2 goes into 64. 2 goes into 6 3 times. 2 goes into 4 twice. We know 2 goes in there. 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. 2 goes into 16 8 times. 2 goes into 8 4 times. So 4 is 2 times 2. We have 1, 2, 3, 4, 5, 6. Why is that important? Because this is a square root, right? How many of a kind do we need to take it out? So as long as we have pairs, they can come out. There's nothing left inside there. So the answer is 2 times 2 times 2, which is 8. How about the square root of 18? Simplify that one. Don't just copy it down. Keep on working out yourself. Because it could be wrong. It could be 2 square root of 3. So what we do is take 18. It's made up of 2 times 9. 9 is made up of 3 times 3. 2 times 3 times 3. There are 2 3s, so they come out. And they're gone inside there. So we're just left with square root 2. There's the answer. E is square root of negative 48. The square root of negative 48. How do we know that number is divisible by 2? The last digit is even or 0. How do we know that number is divisible by 3? If you take 48 and add the two numbers, equals 12. Is that number divisible by 3? That means 48 is divisible by 3. So 2 goes into 4 twice, 2 goes into 8 4 times. It's 12. So this negative inside here, we automatically know that it's going to become an I. And 48 breaks down into 1, 2, 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4, 5 numbers. Here's a pair, so that goes out in front. Here's a pair, that goes out in front. All we have left inside the radical is 3. 2 times 2 is 4, I radical. Getting easier? If you want to, I'll let you take pictures of these at the end. So, yeah. All right, so that is the basic conversion of what we have here. We can now talk about the algebra of complex numbers. What does algebra refer to? Addition, subtraction, multiplication, division. So before we talk about the algebra of complex numbers, we've got to talk about what are complex numbers. Complex numbers are any numbers in this form. Where A is any real number and B is any real number. It's just followed by an I. In other words, if I gave you a number negative 5i, put it into radical terms, how would you do that? We know it has to be negative, so negative has to stay there. There's got to be the number 5. What does I refer to? The negative inside the square root. So this, if I give you this, that's what it came from. And conversely, if I gave you this, that's what this means. You have to be able to convert them in both directions. How about 6i? What would that look like? What's that? Yes. Square root of 25 is 5. Good catch. So this would be what? Square root of negative 36. All right. Is this a complex number? Yes. Is that a complex number? Is that a complex number? We can split these up into 3 over 5 minus 4 over 5i. That's a real number? That's a real number. So yes. Is that a complex number? Yes. It's 2 plus 0i. Trick question. Because 0 is part of the real numbers. And then is negative 3i a complex number? Yes, because you put a 0 in front. So pretty much, like we said, every number is a rational number. Every number is also a complex number. All right, now let's do the algebra. Let's do addition and subtraction first. Add and subtract. This is example 2. A. If I had 8 plus 6i plus 3 plus 2i. Work that out. Remember the order of operations. So first look at the first one, 8. Can we do anything inside the parentheses, order of operations? No. So do we need the first parentheses? Is there a coefficient in front of there? No. So I can just drop those parentheses. Likewise in the second one. Is there a coefficient? It's just a 1. So I never change anything in that case. I just drop the parentheses. Whenever you drop parentheses, what do? Combine like terms, very good. 8 plus 3. Then we have positive 6, positive, so 6 plus 2, 8i, and there's your answer. What's that? That's what it's just imaginary. How about this one? Can we do anything inside the parentheses? No. Do we need the parentheses? Do we need the first one? No, so we just drop that first one. How about the second parentheses? Do we need that? Yes, because it's got a negative in front, we got to distribute that negative sign. So, negative 6 becomes positive 6 becomes negative 6. Positive becomes a negative becomes positive. I mean, there. Now combine like terms. 4 minus 6. Because 6 is bigger, sign's negative. 6 minus 4. They're both positive. 5 plus 3 is 8i. And there's that answer. Combine these. Let me put a pause. Order of operations. We can't do anything inside the parentheses, so we have to get rid of them. 2 times negative 3 is 2 times negative 4. Negative 8i. Negative times positive is negative. 5 times 6. Positive times negative is negative. 3 times 5. 15i. That's 4 times 1 is positive 4. 4 times I, 4i. So we have negative 6, negative 30. So negative 6 and negative 30 gives you negative 36 plus 4. So that takes care of the positive, the real numbers. Now we have negative 8 minus 15. Negative 22i. Negative 22 plus 4. Or 23. 23 plus 4. Negative 19. So it doesn't matter how it's arranged. You can do that. Now comes a change of the rules. If I gave you square root of negative 3 times square root of negative 5, what would that equal? What was that? Anybody agree? Wrong. Oh, now this is what I said. This is where the rules change. Order of operations. Remember, we have to do inside the parentheses first of the operations. So it's negative 1 times 3, negative 1 times 5. Which means we got to distribute those. So what is square root of -1? I times radical 3, I times radical 5. So we have I times radical 3 times radical 5. I squared. Now we can multiply inside there. But the rule is you cannot have exponents on i's. Why? But I equals the square root of -1. If I square both sides, then I squared equals -1. Here's what I'm saying is don't just look on the piece of paper. I'm always going to ask you why. So whenever you see an I squared, replace it with -1. So this one becomes negative square root of 15. There's your answer. Even though it's counterintuitive, because the rule we said earlier, we can take them, we can put them together. So we have -3 times -5 is positive 15, but these are both imaginary numbers. So let's look at example 3.
Just like times 3 and 5, and then just move the negative in front.
No, you can't move the negative front because you have to do each one separately. I see what you're saying, but no. If you do that, it could get very messy when it gets bigger exponents. Square root of 16 times square root of 25. Square root of 16 is what? 4i. Square root of -25. 5i. So 4 times 5 is 20. I times I is I squared. So basically what the I squared does is change the sign of the coefficient in front of it. Because it becomes 20 times -1, which makes it -20. B, we have 1 plus 2i times 1 plus 3i. In school, you've learned a process called FOILing. That only works on these type of equations. If you have a binomial times a binomial, anything bigger and smaller, FOILing doesn't work. So that's why I don't like teaching FOILing. I like teaching what it really is distributivity. It's anything in this parenthesis multiplies to anything or everything in that one. So it's really distributivity. 1 times 1 is 1. Positive times positive. 1 times 3 is 3i. That one's finished. Positive, positive, they're all positive. So 2 times 1 is 2i. 2 times 3 is 6. I times I is I squared. Got rid of the parentheses, combine like terms. 3 plus 2 is 5i. I squared changes the sign in front of it. So it becomes -6. Now we combine like terms. -6 plus 1 is -5 plus 5i. And there's your answer. What's the answer? -42i plus 4 minus 40.
Yep.
Let's see. Did anybody get 9 plus 49? Because there's a plus or minus inside this parenthesis, you cannot distribute. Distributing only works if you have a product of numbers or letters. You cannot distribute inside one of these. So there's 3 squared means 3 times 3, right? So it's whatever's under the exponent, multiply that many numbers of times. So this one becomes 3 minus 7i times 3 minus 7i. So we're back to the distributivity. 3 times 3 is 9. Positive times negative is negative. 3 times 7 is 21. Finished. Negative and positive is negative. 7 times 3 is 21i. Negative and negative is positive. 7 times 7 is 49i squared. Now combine like terms. We have negative 21i minus 21i. They're both negative. 21 is 42i plus 49i squared. The I squared simply changes the sign. Remember, it equals -1, so it changes the sign in front of it. So it becomes minus 49. Combine like terms, positive 49 minus 49, negative 40 minus 42i. And there's your answer. Has to be in that order too. Because remember, complex numbers are in this form. So far, so good. There are possibilities where you can have multiple terms, imaginary terms multiplied together. And when that happens, we can have a larger exponent. Like that. So let's derive what it means. This is called induction. Let me move that out. I is I. It's actually square root of -1, but we'll just call I. I squared is I times I, which makes it what? -1. Because we're always going to build on the previous one, I cubed is I times I squared. I is I squared is -1, so it's negative I. I to the fourth is I times I cubed. I cubed is negative I. So negative I squared. I squared is -1, so it's +1. Let's go on to see a pattern. I to the fifth. I times I to the fourth. I to the fourth is 1, so it's just I. I to the sixth is I times the one we just did, is I to the fifth. I times I is I squared, which is -1. We're almost done. I to the seventh is I times I to the sixth. I to the sixth was -1, so it becomes negative I. I to the eighth is I times I to the seventh. I to the seventh is negative I. So we have negative I squared. I squared is -1, so it equals 1. It repeats itself. It repeats itself in groups of 4. Now, this is important because since it can only be one of 4 possibilities, it could be 1, -1, I, or negative I. There are no exponents in the answers. Why is this important? Since we know it repeats itself in groups of 4, this will help us find this answer. If we take the exponent and divide it by 4, because it goes in groups of 4. So 4 goes into 25 how many times? 6. 6 times 4 is 24. Subtract them, you get 1. This is the number you're looking for. What is this number called? The remainder. The remainder can either be 1, 2, 3, or 0. Because if it has a remainder of 4, remember 4 goes into 4. So it's got no remainder. So again, divide the exponent by 4, find the remainder. Now, if you were running a race and you came in first place, what would you yell? Besides, I can't believe I finished. I won, I won. I won, I won, and the middle 2 are negative. So divide the number by 4. If the remainder is one of these, that's what the answer is. So for our example, I to the 25th, its remainder is 1. So this one can simplify into I. Make sense? Let's try example 4. A, I to the 37. B, I to the 58. C, I to the 75th. And D, I to the 80th. Simplify all of these. So for the first one, 4 goes into 37 how many times? 9. 9 times 4 is 36. Remainder is 1. So it's just I. Let's look at B. 4 goes into 58. 4 goes into 5 once. 4 goes into 18 4 times. Remainder is 2. So it's -1. 4 goes into 7, 4 goes into 7 once. Yeah, 4 times 9 is 36. That's too big. Yeah, so 18. So the answer is -I. Remainder is 0. So the answer is 1. Okay, then what is I to the 243? Four goes into 24 how many times? Subtract, we get 3. So I1, so it's -1. -I, I mean. Easy, much better. All right, so now we got the last part to do, division. The reason it's saved for last is because it has its own set of rules. Remember what it did with square roots? What can you not have with square roots? And the answer, it cannot be on the bottom. No I in the bottom. And the question you can have an I on the bottom, but the answer cannot. So before we start doing this, let's review our multiplication. 2 plus 3i, 2 minus 3i. Do both of these. You don't need your cell phone out. I know, trying to hide it behind your chest cup. Next time somebody does that, we're having a test in class to see what you know. All right, let's look at this. 2 times 2 is 4. Positive, negative is negative. 2 times 3 is 6i. Positive and positive. 3 times 2 is 6i. Positive, negative is negative. 3 times 3 is 9i squared. Combine like terms. They cancel out. This one becomes a plus. There's your answer, 13. How about this one? I'll give the answer right now. But 5 times 5 is 25 plus 5i negative 5i negative I squared. The middle terms cancel. This changes the sign. So give me two numbers. Well, 6 12. So if I multiply it by 6 minus 12i, it'll equal 180. Let's see. 6 times 6 is 36. Positive, negative. 6 times 12 is 72. Positive, positive. 12 times 6 is 72. Positive, negative is negative. 12 times 12 is 144i squared. The middle terms cancel. That becomes a plus. 144 plus 36 is 180. These are a special breed of complex numbers. They're called complex conjugate. complex conjugates are these. The numbers and everything's the same except for the signs between them. They're different. Whenever you have a complex conjugate, the answer will always be the square of the first number plus the square of the second number. It's always going to be that. Let's look at these. What's 5 squared? Here's 1. What's 1 squared? 2 squared is 3 squared is. That's a shortcut. So now, why do we have to know complex conjugates? Because we cannot have an imaginary number on the bottom. What if I had a monomial, a single term on the bottom that has an I? How do we get rid of the I? We can't have it on the bottom. So we multiply top and bottom by I. It'll become 3I, 5I squared. Remember, the I squared changes the sign of the coefficient. That's if we have a monomial. What if we had 4I over 5I? What would you do there? I'd cancel. Yes, you could multiply. Then you get -4 over -5. Negatives cancel, you get 4 over 5. What if you had this? You had a binomial on top and a monomial on the bottom. I would just multiply top and bottom by I. What's that? Ah, good question. The question was, why can't we cancel these? Let's look at. If we had 3 plus 2 divided by 2, what does that equal? 3 plus 2 is 5 over 2. That's what it equals. So if we cancel these, what does it equal now? Wrong. 2 goes into 2 how many times? 1. So 3 plus 1 is 4. Are they the same answer? Which one do we know is right for sure? So if you have a plus or minus, they have to stay together. So if we had 3 plus 2I on the bottom, we'd have to multiply top and bottom by the conjugate of the bottom to get rid of the I. So what's the conjugate? It's 2 over 3 plus 2I. What's the conjugate? 3 minus 2I. So on top, we have two times this, which is 6 minus 4i. We distribute the two across, and the bottom, we're multiplying two conjugates, so it's 9 plus 4 is 13. Again, we can have an imaginary number on top. We still multiply by the conjugate of the bottom. So the bottom, we know is going to be 13, 3 squared plus 2 squared. So now we have 6i minus 4i squared makes it 6i plus 4 over 13. So the answer is 4 plus 6i over 13. And if we had binomial over binomial, just multiply them out. That's it for that section. That's it. That's it for section 1.